Kia ora, Year 12. This complex numbers question has got two parts. The first part is fine, and the second part is actually pretty awful for 4 marks. So I think what I'm going to do is to split this video up and do the first part now in a really short video, because I want to show you about probably 3 different ways that you can do that second one. So the second part is especially for people who are overall going pretty well, and the first part is for people who are feeling like they're still in catch-up mode. So we're given an equation. We've got a cubic z cubed plus 2z plus a is 0, and a is real. So that means we know that we can apply the conjugate root theorem when we're looking for the roots. We're told that this is a root of the equation, and we have to figure out what a is, and we have to give the root the other complex root of this equation. So straight off, we can say that -1 minus root 5i is a root by the conjugate root theorem, right? The coefficients are real. So there's 1 mark right there. So a couple of ways to go here, and some of you have done both of them. You can substitute that in there and work it through to find a. I'm not going to do it that way. I'm going to do it by saying, well, we know 2 roots now, so we can get a quadratic out, and then we can do matching to work that out. And that worked out pretty easily. So we know that this is a factor, so z minus -1 plus root 5i is one factor, and this one here will give me the other one. So z minus -1 minus root 5i is also a factor. I'm going to clean that up and get my real and imaginary together. So we've got z plus 1 minus root 5i times z plus 1 plus root 5i. That gives me z plus 1 squared, right? So this, working with this, these disappear. That's how the conjugate root theorem works. And then I've got minus 5i squared. So minus -5. That cleans up to give me z squared plus 2z plus plus 1 plus 5. 1 times 1 is not 2. Giving me a quadratic bit of z squared plus 2z plus 6. Okay, so that's my first bit done, and now I have to match it up with this. So doing matching on that, in order to get a, will give me this. Z cubed plus 2z plus a has to equal this, and then it's going to be times z plus this. I'll call that k. Doing a bit of expanding, I'm going to expand on... I think I'm just going to expand the whole thing out to show people who still need practice at this. So I've got z squared, all of this times this, so z cubed plus 2z squared plus 6z. That gives me that bit there. Hang on a sec. Where's my pen gone? Plus kz squared, right? So this is the number we don't know. Kz squared plus 2kz plus my constant of 6k. Now, we know that that has to give me whatever. I know that there's no quadratic term. So 0z squared has to be coming from 2 plus kz squared, which means that k is equal to -2 and a is equal to -12 from here. So that's that bit done. A is equal to -12, and we've already done the other complex root, which is this one up here. So that's that question done. Short video there, because I'm going to need probably a good 10 to 15 minutes for the next question. So I'll do that later on when I've charged my laptop up.